All right, the next section, 8.1, is on conic sections, and we're going to focus on parabolas first. So we're going to learn conic sections, we'll learn the geometry of a parabola, we'll translate some of these parabolas, and we'll use the reflective property. So here's the example of a conic section. If we take two cones and tip them up like this, that would be a conic section. And from that we can get these different shapes. So if we could take a plane and we cut the conic section like this on an angle, we're going to get an ellipse. If we cut it like this on a different angle, we could get a parabola. And if we cut it straight up or straight down, we'd get a hyperbola. We could also get a point, a line, and an absolute value function, kind of like a v, if we cut it just right. All right, the next thing is we're going to do, these parabolas are actually second-degree quadratic equations that look like this. This might look really confusing. But we are going to take equations that are like that, where they're second-degree quadratics, and we're going to complete the square and put them in standard form for parabolas, which I'll show you about in a second. But first, a parabola, what a parabola is it's a set of all points that are equal distant from the focus and the directrix. So this point right here, for example, if it's equal distant from the directrix to the focus. So if this length is 7, then this length needs to be 7. And that goes for all points. So this point right here, if this length is 1, then this length is 1. All points on a parabola are always equal distant from the focus to this directrix. And the directrix is just a line that would be tangent to the circle if you moved it, 1 unit this way in this case. It's a line that goes behind the parabola. Okay, so we're going to look at graphs of different types of these. If we have x squared and if we have y squared. Now, if we have x squared, that's going to be a parabola that opens up or down. You're familiar with these. In which case, the directrix is going to be a horizontal line. Okay. So here's a summary of all that information. Then I put all this on the formula sheets. None of this you're going to have to remember. And in fact, let me scroll down to the part that has not centered at the origin, which would be this right here. So here's what I have on the formula sheet. All this information summarized for you, and this is what you're going to want to be able to access for every single problem. So let's do an example right here. Here's an example of finding an equation of a parabola. They're going to give you different things, but the first one gives you the vertex and gives you the focus, and it wants you to write a standard form equation. So on the formula sheet, if you pull that up, here's all that information. So I'm going to copy that over. All right, now from here, I have the vertex, which is hk, and I have the focal point, 1, -2. So I like to draw a rough sketch of this real quick. The vertex is at 1, 2, which is right here. And the focus is at 1, -2, which is down here. So what that means then is the parabola opens this way. And I can draw the directrix in as well, because if this length is 1, 2, 3, 4, then I could go up 4, 1, 2, 3, 4, and draw a horizontal line for the directrix. Because I know the definition of a parabola is that this point is equal distant from the vertex, and the focus is equal distant from there as well. So I know that this distance right here in this case is 4. Okay. Now they want us to write a standard equation. This is a parabola that opens upward or downward, so I'm focused on this column right here. So I have x minus h. H is 1 equals 4p times y minus k, and k is 2. So the only thing I need to find now is p. Now they gave me the focal point, so I can use that with the information that they give us right here. H is 1, comma, k is 2. So this would be 2 plus p. So there's the focal point, plugging in h and k, and I know that has to be equal to 1, -2. So you can just compare now and say, well, 2 plus p has to equal -2. And therefore, p equals -4. All right, so you plug in -4 here, and this gives you -16 right there, which is what we're looking for. So there's my equation that they asked for. Now, another way is you can understand that p is just this distance from the focus to the directrix, but because you're going down, it's going to be -4. It's another way to look at p. But there's the equation for the parabola. Now, obviously, we're used to solving this for y and having it in like vertex form or standard form for a parabola, but this is just fine. We're going to leave it in this form for right now. Okay, so the next example I'm going to do then is one where I'm going to use a function grapher to graph this parabola. So if I graph this, first of all, I know that if I get my formula sheet over here, I know what this looks like because this is y minus h squared. I'm sorry, y minus k squared equals 4p times x minus h if you just compare to this column right there. All right, so we know some information from that then. We know h and k. So k is -5 and h in this case is 1. That means the vertex is at 1, -1, 2, 3, 4, 5, which is right there. We know this thing opens right or left. We know the focal point then is at h plus p comma k. So p must be -1 in this case. So if you just plug into this, h is 1 plus p is -1, that'd be 0, comma k is -5. So 0, -5, this point right here is the focal point, which means the parabola is going to open like that around, in which we know the directrix then would be the line x equals 2. So you can graph it just from this information because I give you all the information you need. But this one wants to use a function grapher. So another way to do this with a calculator then is to solve this one for y right here. So if I square root both sides, I get y plus 5 equals plus or minus the square root of -4 times x minus 1. And I'm going to then subtract 5 from both sides as well. And now I have a function for y right here. I'm going to plug this into my calculator. Now I plugged in the positive, and the negative. The negative went in the second one. And then I can take a look at this graph. Now I'm going to need to change my window a little bit. Maybe a standard window would actually just work fine, which I was zoomed in a little bit. And you can see that this is the parabola that we were talking about, and it does open left or right with the vertex in the right spot and everything like that.